Hello, this is the Week 4 Homework assignment for Carrie Johnson. For this assignment, I have selected problem 11.13 from the textbook on page 639. In this problem, we are asked to run the retirement model from example 11.6 using a damping factor of 1.0 rather than 0.98 that was used in the example. We're asked to explain what this change in damping factor means with regards to the simulation and the effect or differences, if any, that changing the damping factor has on the simulation results. I am beginning with the setup used in example 11.6 from the book. You'll see that I've already entered all of the formulas necessary with the weights, with the probability weights, calculated probability, the investment weights. I've also calculated all of the different formulas for the beginning and ending cash flows for 40 years, as well as the final cash in today's dollars. So by changing the damping factor from 0.98 to 1.0, essentially what that's doing is weighting all of the probability of all of these historical years as the same. Because the damping factor is now a factor of 1, all of the years between 1946 and 2007 have the same probability as each other. There is no longer a greater consideration for more recent years. The book addressed this in the example by explaining that using risk discrete was necessary for the scenario because there were different probability factors for the different years rather than using rand between function. In this case, it would be just as appropriate to use rand between because the probability are equally distributed. And now that I've changed the damping factor, I will rerun this simulation with 1,000 iterations and again 3 simulations. As you can see, I've completed the simulation running this with a damping factor of 1. In assessing these results, I do not see a dramatic difference in the results from running the simulation with a damping factor of 0.98, in that I still would expect that the simulation, the first simulation, which is most heavily weighted in stocks, outperforms the other two simulations. The results are very similar to the results in the example, in that the average is about 154,000 and the minimum is only slightly worse than the other two simulations, but the maximum is about 378,000. As the book referred to, though, the 5th percentile is a bit concerning in that this is estimating about $35,000 as a result, and given that the customer is investing $40,000 in today's dollars, that would actually represent a loss. We might need to revisit the distribution and reconsider that portfolio mix. This concludes the homework assignment for week 4 for Carrie Johnson.